Good morning, guys. This is a video for solving quadratic equations using the quadratic formula. And this is on page 21 of your Unit 1 resource. So the key for using the quadratic formula is to make sure that your quadratic is set equal to 0. Okay? If it's not equal to 0, it doesn't work. So the first thing you're going to notice when you get down here to the first example is that it's not equal to 0. So the first thing we have to do is take the negative 21 and add it back to this side of the equation. So the equation that we're going to use for this first problem is x squared minus 10x plus 21 equals 0. Alright, so then once we get that fixed, because that had to be fixed, the quadratic formula, which is right here, notice that inside the formula there are no x's. It's only a's, b's, and c's. So when we are using the quadratic formula, and we have our equation, we want to make sure that we are only using the coefficients of a, b, and c, and not the x's in the equation. So just to come down to the problem and write it down, we're going to have a is going to be 1, b is going to be negative 10, and c is 21. Now you probably are going to want a calculator with this, okay? Because some of our numbers are going to get big. We start squaring, adding, multiplying, and subtracting. Alright, so inside the quadratic formula, it is x equals, this is a really long fraction bar. We're going to use negative b, which is to say that we're changing the sign of b. And so since b is already negative, we're going to use a positive 10 for the b value. Plus minus comes after that. We get a square root. It is negative 10 squared minus 4 times the a times the c. The a is 1. The c is 21. And so this is where you'll really want the calculator inside that multiplication. On the bottom is 2 times 1, which is the a value. Okay, so let's use the calculator and just kind of clean this up a little bit. So we're going to have x equals 10 plus minus all over 2. And so I'm going to use the calculator to calculate what this value is. So we're going to go to the calculator. So we have negative 10 squared minus 4 times 1 times 21. So we get 16 out of all of that. So underneath the radical now, we just have 16. And so what that allows me to do is kind of clean this up a little bit, make that a little bit smaller. And so we are going to take the square root of that 16. You get 10 plus minus 4 all divided by 2. Now one of the things that we'll notice here is that the 10 and the 4 can actually be added and subtracted. So we're going to get rational answers here. So what we really need to understand is that we have 10 plus 4 divided by 2, and we have 10 minus 4 divided by 2. And these are going to be the two answers that the quadratic formula is going to give us. So x equals 10 plus 4 is 14 divided by 2 is 7. That's one of our answers. And 10 minus 4 is 6, divided by 2 is 3, and that's our answer. Okay, so let's try another example. So this equation is set up ready for us. It's in standard form. We can see that A, B, and C exist, and it's equal to 0. So A will be 1, B will be 6, and C is 9. So let's get into the quadratic formula. X equals negative B, so change the sign of B. Negative 6 plus minus square root 6 squared minus 4 times 1 times 9. All divided by 2 times 1. Okay, let's grab our calculator and calculate what's underneath the radical. Don't put the square root in the calculator. That's not going to help you out. So 6 squared minus 4 times 1 times 9. And you'll find that it is 0, and that is correct. So don't freak out if you get a 0. So that gives us x, wrong color. X equals negative 6 plus minus square root of 0, all divided by 2. Well, hopefully you guys are realizing that that just basically disappears. Because the square root of 0 is 0. And so we end up with x equals negative 6 divided by 2. So x equals negative 3. And that one only has one answer, which tells us that that only crosses the x-axis in one place. Okay, example number 3. So we've seen where a problem had two real solutions. They were unequal, they were different. We've seen example 2 where it only had one real solution, so that one hit the axis one time. So this one's going to be different. Okay, different is good. So A here is going to be 2, B is 8, and C is negative 6. All right. So let's see what happens. X equals negative B. So change the sign of 8 plus minus 8 squared minus 4 times 2 times negative 6. All divided by 2 times 2 is the A value. So let's kind of simplify that, get rid of our calculator ready. Negative 8 plus minus all over 4. So let's see what this calculates. 8 squared minus 4 times 2 times negative 6 is thus 112. All right? 1, 1, 2. Now, obviously, that's not a perfect square. The first example had 16 as a perfect square. The second example had 0, so that completely disappeared. Here we have 112, which means we're going to have to simplify that radical. So let's see what happens with that. So 112 divided by 2 is not a perfect square. 112 divided by 3 is not a perfect square. 112 is not divisible by 5, so I won't even try that. 6 That's not the right number. 112 divided by 6 is not good. 112 divided by 7. 16. So there's our perfect square. So if you just keep trying, you'll find it. So this was 16 times 7. Alright, x equals -8 plus minus 4 square root of 7 divided by 4. Now, what you're going to notice is that this 4 divides into the 4 and divides into the 8, and we have to simplify that. The 7 is done. We don't have to touch the 7, so we're good there. So we'll divide the 8 and the 4 by 4, and we'll be done. So x equals -2 plus minus 4 divided by 4 is 1, which leaves us just the square root of 7. And that finishes up our third example of two irrational, unlike answers. Alright, so next we talk about something called a discriminant. And discriminant is something that you guys have actually already calculated, that you just didn't know it existed. You didn't know where it was. So we use our calculator to make a calculation. And so this, b squared minus 4ac, right here, which is underneath the radical, is called the discriminant. And what it does is it tells us the number and type of roots for the quadratic equation. In other words, are they real? Are they imaginary? Does it cross the x-axis? 1 time, 2 times, or none, right? So we've seen where the parabola can cross it 0 times, 1 time. I'll have to fix that one a little bit off. 1 time, or that it can cross it 2 times. Okay? So here we have complex. This is 1 real, and this is 2 real. Okay? So that's where we're going to be able to determine, that's what the discriminant is going to tell us. So there's 3 different options, right? So you have 1 option, 2 options, 3 different options for types of answers and number of answers. Okay? So we look at the value of the discriminant. And so if the discriminant is positive, there will be 2 real roots. If it's a perfect square, they're rational, meaning no radical. If the number is not a perfect square, then they will be irrational, which means you'll have a radical in the answer. And so we saw one of those on the previous problem. So, sorry about that. We saw one of those on the previous problem. The second option, if the discriminant is the number 0, which we also saw, then there will be 1 real rational root. And so that was our second example where we just had an answer of -3. And if we go back and we look at, the third option would be that they are complex. And so when we have a discriminant that is a negative value, you get 2 complex, otherwise known as imaginary roots. Remember that roots are where it crosses the x-axis. So here, your discriminant would be negative. Here, your discriminant would be 0. And on this far right side, the discriminant would be positive. I'm going to rewrite that because I don't like the word positive right there. Okay? So that's what the discriminant does for us. Okay, so here are some discriminant examples. Now what it's asking us to do is to go back and look at the first 4 examples. So we're looking for the number that is underneath the radical. There will be a number. So this is example number 1. We have a 16. Example number 2 is 0. Example number 3 is 112. And example number 4 is negative 16. So that is 16, 0, 112. Sorry, I'll rewrite that. And negative 16. Okay, and what we just finished talking about was these numbers will either be one of 3 categories. They'll fit into one of 3 categories. They'll be positive, they'll be 0, or they'll be negative. And based on that, it tells you how many solutions each problem has. So if the discriminant is positive, it has 2 solutions. If the discriminant is 0, it has 1 solution. And if the discriminant is negative, it also has 2 solutions. So since 16 is positive, it has 2 solutions. Number 2 is 0, it has 1 solution. The number 112 is positive, therefore it has 2 solutions. And example number 4 is negative, so it has 2 solutions. Now all that information is based on this chart right here. Positive gives you 2 answers, 0 gives you 1 answer, and negative gives you 2 answers. Now comes the nature or the type of solutions that it has. So if it is positive and it has 2 solutions, then it's based on, is it a perfect square or a non-perfect square? 16 is a perfect square, therefore it has 2 unequal rational solutions. We'll do the other positive one since we're there. Talking about positive numbers, and this all, again, it comes from this chart. Perfect square says they're rational. Non-perfect square says it's irrational. So this 112 is also going to have unequal answers, meaning they are different, but they're going to be irrational, meaning it's going to have a radical in its answer. All right, so then the next one is the 0. So if it has a discriminant of 0, it has 1 solution. Ooh, wrong way, I'm sorry. 1 solution, and it is, I'm sorry, it has 1 real rational answer. So this would be real and rational. And our last example is a negative, therefore had 2 solutions, and based on the chart, the negative has 2 imaginary answers. So we can come back here and just say that they are imaginary. All right, so let's take a look at these last three examples. We'll calculate these real quick. B squared minus 4AC is 3 squared minus 4 times 1 times 5. And that calculates to be negative 11. So our discriminant is negative 11. So how does that match up? That is a negative answer. Therefore, has two imaginary solutions. The B example, negative 11 squared minus 4 times 1 times 10 is 81. Sorry. Which is positive, so it has 2, and it is a perfect square, so therefore they are rational. In our last example, 8 squared minus 4 times negative 5 times negative 1 comes out to be a positive 44. You can check the calculations if you want. That's what they are. That is a positive answer, so it has 2. 44 is not a perfect square, therefore has irrational answers. Again, all this information can be interpreted by this little chart on page 22.